Conservation of momentum is the thing we're gonna solve now. That song was much more compelling in my head. Here's the deal. We have a 50-kilogram cart and a kid riding the cart, and he jumps off, so he hits the floor with 0 velocity. So here's the deal with conservation of momentum. What to look for? Look for 2 objects and speeds, and then you know you're good. So here's the deal. We have this cart, we have a kid, okay. They're both going at 2 meters per second. The kid jumps, speed is 0, cart keeps moving. So let's set it up. The formula is M1V1 initial plus M2V2 initial equals M1V1 final plus M2V2 final. Keeping that in mind, we can go ahead and set this up in the following way. So we have 50 at 2 plus 70 at 2 equals the kid jumps off and stays, I got it backwards. I should really call this V2 final and V1 final. Not that it matters, but I just want to keep it clear. So we have the 50 cart moving at 2 and the 70 kid moving at 2. Then the 50 cart continues at its unknown final speed, and the kid is now at rest. So we have 100 plus 140 equals 50 times V1 final. We end up getting 240 equals 50 VF. We can isolate. So 24 over 5 is V final, and that ends up being 4.8 meters per second. Awesome. This question here, this is a really obnoxious problem because they just don't make it clear. I hate this one. Look, if you haven't done this one, I'm just going to say skip it. I'll give you a better version in class to practice with. So if you're like, oh my goodness, no, I don't, please do the solution. Let me put it out there. This is worded really poorly. And it's got a lot of gotcha stuff that I would never put on a test, especially in an accelerated class. But there's some good physics here. So I'm going to rewrite this problem just as maybe a warm-up for tomorrow, and I'll kind of address that in class. So looks like we've got all the homework 5 videos made, and I'm just going to continue cranking out material, making sure you got stuff to support you for our exam on Friday.